with this video I want to try and explain to you how to trace the binary search, and that's how to answer it, because very few students get this right. So if you look at the first slide here, we're just going to look at the code. It starts off by initializing first to 0, that is the first position in the list, and last to list.count -1. In this case, last is thus 7. Please note that if you look at the array, the bottom row is the elements in the array. But when we trace the binary search, the first, last, and mid, we always only work with the positions. So in this case, 0 and 7 for first and last. Right, now let's look at the top of the while loop. The while loop carries on while first is less than or equal to last. That will only change when you're not finding something. In that case, at some stage, first will become greater than last, and then it will terminate. The first thing that happens inside the while loop is it calculates mid. In this case, it's 0 plus 7 divided by 2, so mid is 3, and it points to position 3 in the array. In this part of the loop, the search says, have I found the thing that I'm looking for at position mid? So if we were looking for 12, it would say yes, 12 is at position 3, and therefore we return, and notice what do we return? We return mid. So we return that we found 12 at position 3. But what happens if we were looking for something that was less than 12? Let's say we're looking for 7. Then this if statement says if it's less than the one in the middle, then last must become mid -1. What does that basically means? It means that if we were looking for 7, then clearly it's in that part of the array before position 3. So since we are looking for something less than 12, as we said in the previous slide, last becomes mid -1. So now we're looking at 0 being first and last being 2. And then we go to the top of the while loop and notice what happens. So at the top of the while loop, we see that first is still less than or equal to last. And then we calculate mid to be 0 plus 2 divided by 2, so mid is 1. So in this case, if we were looking for 7, we would have found 7 at position 1. Okay, so let's see how you would answer a question like this. We're looking for 22 in this list. So we start off and we initialize first to 0 and last to 7, and mid is 0 plus 7 divided by 3. Please note that we're not saying 4, 16, and 12. We give the positions 0, 7, and 3. Okay, so we're looking for 22, and we say, is 22 at position 3? So clearly 22 is not at position 3. So according to the binary search, what now happens is first must become mid plus 1. So first becomes 4, last stays 7, and how do we calculate mid? It's 4 plus 7 divided by 2, so mid is now 5. So we say, is 22 at position 5? So clearly 22 is not at position 5, it is greater than the 20, which is at position 5. So because of that, first becomes mid plus 1, so first becomes 6, last stays 7, and mid is 6. 6 plus 7 is 13 divided by 2 gives you 6. So now we say, is 22 at position 6? So clearly 22 is at position 6, and if you look at the binary search, it returns the 6 because it found 22 at position 6. And the answer you would give would be those values 073, 475, 676. Please do not get confused and give the values in the array. You're giving the positions, and that's how you would answer the binary search trace.